Just a review of function notation hopefully for you. If I have an equation, this is an equation. Y equals 3x minus 8. How many variables are there here? 2. Which one is the independent variable? The independent variable is x in this case, right? Typically for equations like this. And then the dependent would be y, typically. Function notation is over here. The equation here is f of x. That's how you read this. I'm going to put that on here. You read it as f of x equals 3x minus 8. And the f, typically we use f for function notation because f stands for what word? Function. So f of x, the function of x is 3x minus 8. How many variables do we have here? 2. What are they? X is one of them. What is the other one? F of x. This whole thing right here, you can treat as a variable. It's like y over there. The function notation just tells me that my function is in terms of x. This is my independent variable right here. The x is. This thing changes depending on what happens over here. Over here, we have y changing depending on what happens with x. Here we have f of x changing depending on what we do to x. It's the exact same thing. They are interchangeable. You can go from that to that or backwards if you need to. Don't get confused about the notation here. It's just a name. It's like John. This function's name is John. Okay? Actually, this function's name is f of x. This is a variable. It's not f times x. You can't get x by itself here by dividing by f. This is a name. That's it. That's all it is. The advantages of function notation are, you know which variable is independent automatically. If I were to give you an equation like this, which variable is the independent variable? Could be either one. Do we know which one it is here? Sure. Could it be n? Could it be m? Could it be either? Could it be neither? That's the problem with regular notation like this. We use y and x most of the time, and most of the time the x will be the independent variable and y will be the dependent variable. But in the instances where we have other variables going on, we don't know which one's which. We don't know which one to put on the x-axis, unless we really think about it. That's where function notation is nice. Because here, there is no doubt. Because of the function notation, x is my independent variable. It has to be because of the way that this is written. It has no choice, which makes this my dependent variable. So that's the advantage of function notation. Number 2, you can easily substitute and keep track of the work that you've done as you go. There's a lot of times when you might have a function like this, and it says evaluate the function at these certain points. Like maybe there's like 8 points in a row that you have to evaluate it at. The function notation is a good record-keeping tool because then as I substitute in those numbers, I know exactly which one I am using. You'll see how that works here in a second. All right, to use function notation, we have a function down here, f of x equals negative 4x plus 7, and I want to find each value. So what I'm going to do is, this is telling me to find the function at 2. The nice thing about the way that that's written is, now I know exactly what I have to do. I'm going to substitute 2 in to my function up here. This original function is f of x. Now I'm finding f of 2. Well, what happened to the x? It turned into a 2, which is telling me to substitute 2 in everywhere I see x in my function. So I'm going to write my function equals negative 4, and I'm substituting that 2 in everywhere I see x, so negative 4 times 2 plus 7. Negative 4 times 2 is negative 8 plus 7, so I get negative 1. My answer, f of 2 equals negative 1. Yeah, that's the answer. You would circle it, but that's the answer. f of 2 equals negative 1. What is the function evaluated at 2? It's negative 1. That's what that says. Now the nice thing is, if I had just y equals negative 4x plus 7, and I said find out what the function's value is at 2 and negative 3 and something else, you would wind up with y equals negative 1 here, and then you'd have to say something about that. When x is 2, y is negative 1. That's how your answer would have to look. Instead of something neat and clean like this, f of 2 equals negative 1. We're actually making your life simpler by using this notation. So go ahead and try f of negative 3, same way. And what do we get? Like, what do I write first? Yep. Plus 7. And then you just continue. F of negative 3 equals, we got negative 4 times negative 3, which is 12, plus 7 is 19. Good enough. That's the answer. The whole thing is the answer. How about f of a? What am I going to have to do there? I'm doing exactly the same thing as I just did. I'm substituting a in, though, instead of an actual number. So I'm going to write equals, and then I'm going to write negative 4, parentheses, I'm substituting an a for x, plus 7. Is there anything I can do to simplify this? That's the answer. So I could rewrite it as f of a equals negative 4a plus 7 without the parentheses, and that's my answer. You're just substituting in what they're telling you to substitute in right there. Whatever it is, substitute it in, and then simplify it down. So now we have a new function, h of x, this time equals 3x plus 4, and I want to find each value. I think we probably know what to do with h of 0, right? So we plug it in, we're going to write what? Okay, so h of 0 equals 4. And that's the answer. Okay, I'm going to give you an option. I'll do either this one or I'll do this one. Which one? Top or bottom?
The top.
The top one? Okay. What this says is I have 3 and then no notation in between, and then I have a grouping symbol. So what does that mean I'm doing with my 3? Multiplying. So inside the grouping symbol I have the whole function h of x. What this says is 3 times the function h of x. What is h of x? Yeah, it's just sitting right here. That's h of x right there. So the 3x plus 4 is going to go in right here. I have 3 times the 3x plus 4. So what could I do now? Distribute, yep. 3 times 3x is 9x. 3 times 4 is positive 12, so 9x plus 12. So I'm going to write 3 bracket h of x equals 9x plus 12. That's my answer. All right, that was your choice for me to do that one, so you guys now get to do these two. You can work together if you need to, but I want these two done. So what is this saying? What is this problem right here trying to get me to do, like in words? What's this tell me to do right here? Yeah, my function is h of x. This says h of 2. It does not say h times 2. It says h of 2. So that's like maybe a source of confusion right there. This says take my function h of x and substitute 2 in. Once I do that, I'll have a number, right? I'll have an answer. And then what am I doing to that answer? I'm adding 4 to whatever I get. So I want to find h of 2 first, which means I'm going to substitute 2 in up here. H of 2 is 3, parentheses, 2 plus 4, which is 10. So now to answer this problem right here, h of 2 is 10. What am I doing to h of 2? I'm adding 4 to it. So I have 10 plus 4. The answer is 14. Notice that as I was evaluating h of 2, I did include an equal sign because I'm using an equation up here. But in the end down here, I do not have an equal sign because this is not an equation. This is an expression. There is no equation in that problem. Here off to the side, sure, because I'm using an equation to find out what h of 2 is. But once I have it, I come back to my problem, and there is no equal sign. Because there's no equal sign, that means I cannot use any of my properties of equality that I normally use on an equation. There's not an equation. Okay, for the second one now. Now that you've seen that one, and you've seen this, can we piece those two things together to do this? What should we do? What do we do? All right, so you're trying to find h of negative 2, right? We have h of negative 2, whatever that is. I don't know what it is yet. And then we're going to subtract from it. What does this say? Okay, so we probably ought to figure out what h of n is, and then do what to that? Multiply it by 2. And then we'll have this one, and we'll have this one, and then we're going to subtract the 2. And then simplify it down. Maybe we'll get a number, maybe we'll get a letter, I don't know. We'll see. Okay, but that's the idea on how to do this problem. So let's find h of negative 2 first. What is it? Negative 2 times 3 is negative 6 plus 4 would be negative 2. So this thing right here, h of negative 2 is what? Negative 2. So that's this. Now what should we do? Find h of n. So this part right here will become 2 times whatever h of n is. So I take that n, I substitute it in right here for x, and I get 3n plus 4. Okay? H of negative 2 is negative 2. 2 times h of n is 2 times 3n plus 4. What are we doing to these two things? We're subtracting them. So I'm going to write negative 2 minus 2 parentheses 3n plus 4. I took the two parts, figured out what they were, and now I've put them back together with that subtraction that's in between them. Now what can I do? Yeah, simplify it down. Combine like terms, whatever it has to happen so that it becomes the simplest possible form. I can't do anything to the negative 2. I can distribute. What do I get? Negative 6n minus 8. I like it. Now what? Combine like terms, and I get negative 10 minus 6n. Negative 6n minus 10. Same thing. There's your answer. Don't let the function notation mess you up. Our function h of x, this tells me substitute negative 2 in. Figure out what that is. It was negative 2. My function h of x turns into h of n. Substitute n in, and then multiply it times 2. That's what we did right here. This says subtract those two things, so I did. All right, break this thing down so that it's not so complicated looking. Tickets to the Miley Cyrus show are still available for $35 online, plus a handling fee of $250 thanks to Ticketmaster. Anybody going to that show this weekend? I'm going. I won't be here Friday. I'm going to the Miley Cyrus show. No. Well, when people wonder where I'm at, tell them I'm at the Miley Cyrus show. All right, handling fee of $250. The total cost is a function of the number of tickets bought. We're supposed to write a function rule. So we have the total cost is a function of the number of tickets. Write a function rule. That means we're going to use function notation to model the cost of the concert tickets and then determine the cost of buying 4 tickets. So I want function notation. What is our variable here? What's the thing that's changing? The number of tickets. Where is it? Function of the number of tickets. They're actually telling you what the variable is here. It's a function of the number of tickets sold. So if I sell more tickets, what's going to happen to the amount of money I got to pay? Or if I buy more tickets. Okay, so my variable will be what? T equals just tickets. I got some tickets. Number of tickets. Okay. T is the number of tickets that you buy. So now I need to write a function in function notation. How can I do that? F of t equals, and now I write my function. It's $35 per ticket. So 35, use the variable you defined, 35t, plus a handling fee of $2.50. That's the question. Is that handling fee applied to every ticket, or is it just applied once? Tickets are available for $35 each plus a handling fee of $2.50. That is implied to be per ticket. So actually, what do we have here? Plus 2.5t. In other words, my function is well, what is that? How much am I paying per ticket actually here? $37.50. There's your function. Now it says determine the cost of buying 4 tickets. So what will I write? No, what will I write? F of 4 equals. Now we substitute in. And what is 37.5 times 4? What is 0.375 times 4? What is 3/8 times 4? Would have been 3/2, which is 1.5, which is... So you get $150 for those 4 tickets. Luckily, I only bought 2, so I only had to spend $75.